I'm Nick Bateman. I'm the entomologist here at the station. Today I got Gage Maris. He's a PhD student under us, me and Ben. Well, you've been here 3 years now? He's been here almost a decade between like being a summer worker and working on his degree, but you know, just a general update of what we've seen this year from an insect side, particularly in rice. You know, it seemed like in general our rice water weevil pressure was a little bit lower this year. And I don't know that it was actually lower or if it was all the rain, the 40 inches some odd of rain we had this spring. If we had so many natural areas just flooded and so many fields that, you know, had basically a flood on it for a couple weeks here just due to all the rain. And they, instead of seeing that one big push that we normally see around the 1st of June, if it wasn't more of a trickle effect over a long period there. You know, from a control standpoint, Gage is going to touch on some of this as well. You know, seed treatments are still our best option there, and particularly adding like a diamide seed treatment, a Fortenza or Dermacore. You know, typically with those products, we see 80+% control there, a lot of times 90. This year it was a little reduced, and I think it's purely related to how much rainfall we got. You know, those seed treatments, the diamides, they're not super water soluble, but whenever you put them through that much rain, it's going to dilute them out over time. It's going to move them through that soil profile. And I think that may be one reason we saw a little bit of reduced efficacy here this year, pretty much across all your sites, wasn't it? But one thing Gage is working on, you know, whenever it comes to adult rice water weevils, we've had a threshold since what, the mid 80s, somewhere in there, late 70s, mid 80s. And it's always been based on scarring, and it's scarring on the new leaves, and you stop at multiple places. Depending on how many you got out there, you may or may not treat for those adults. What Gage is trying to do is use a sweep net and develop a threshold about that, and he's looking at some time of day things. I'm gonna turn it over to Gage, just tell him what you've been doing and what you're seeing.
Right, so like Nick said, one of the main goals of my project is to develop a threshold for adult rice water weevils using a sweep net. So we have had since, I believe it was published in the 70s, a threshold based on the number or the amount of leaf scarring that you're seeing out in the field. And with my project, we were kind of trying to triangulate our scarring and then our larval counts, which we have an established threshold for rice water weevil larvae of 5 larvae per core, and then we have our scarring threshold, which is set at when 40% of new leaves on 40 rice plants throughout the field in 4 different spots have scarring present, that would trigger an application to treat for adults. And so we were kind of trying to triangulate all that, but what we ended up finding was that our scarring threshold is not as accurate as we had thought. Or was indicated when it was published, and that could be just because of varietal changes or anything like that. But one thing that kind of highlights that is we have a location up in Pine Tree, which is our like kind of rice water weevil honey hole. We have like really high pressure there every year, and then another location of this study down in Rower. And if we look at last year, at Pine Tree, we walked out there, and before the flood even went on, when our weevils would come, we already had 100% scarring in those plots, and so we would have already triggered an application there. But then when we go down to Rower, where our moderate population is, it took a couple days, but then around 3 days after flood, before the peak of our weevils get out there, which is going to be at 7 days after flood, we had 100% scarring already there too. So. And then when we pulled our cores and examined the number of larvae that were in each, we saw a significant decrease, but from Pine Tree to Rower, even though our scarring threshold would have indicated that those populations were about the same. So what we're seeing with the scarring threshold as a whole now is that it's going to kind of be a are they there or are they not there type of indicator. Whereas instead of being able to quantify how many adults we actually have in the field. And so we're leaning on this sweeping threshold. We don't have like a solid number, like a number that we can say this many adults equals our threshold of 5 larvae per core, where we would see economic damage at that point. But right now we're thinking about 1 per sweep, so 10 on 10 sweeps or 25 on 25 sweeps. But one thing with our sweeping of rice water weevils that we found in the past 3 years has been that how many we catch is going to be heavily dependent on the time of day that we're out there sweeping. And so this was kind of something that we just noticed kind of offhand my first year, that the later we would be out there sweeping, the more adults that we would catch. And so we set up that first year just kind of a quick trial where we swept in the morning around lunch and then like later in the evening around 4 or 5. And we found that every time we come back, we have an increase in adults. And so we have replicated that each year since and expanded it this year especially. And so last year we had a really high rice water weevil populations, and we saw that that trend throughout each location that year. So typically in the morning at Pine Tree one day, this was at 7 days after flood, which is going to be our peak of rice water weevil adults in the field. We came and in the morning we were catching like 10 on 10 sweeps, just kind of, you know, moderate numbers. And we came at lunch, and that had increased a little bit. I think we were in the high teens, low 20s. But then when we came back that night, we were catching like 100. In I think my second set of 10 sweeps, I caught like 350. And so we're in the same field. And so we're really seeing a difference in the number of adults that we catch based on the time of day that we're out there. And so we're continuing this study so that we can kind of nail down like a ratio where we can say, if you go and sample in this time block, say in the morning, if you go and sample in this time block and you're catching X amount of weevils, you multiply that times a certain factor to know how many you would catch later in the evening. And so this year we've done a couple of things to try to understand why that difference, why we're seeing that difference, like setting up some cameras to try to go through and watch what the weevils are doing throughout the day. But we're not 100% sure where they are.
It kind of seems like, which, you know, it's been known forever, right? Since people started working with rice water weevils, they're more active at night than what they are during the day. That's where a lot of the mating and general adult feeding and stuff's going on. So it makes sense for them to be more active during the evening. But those weevils aren't leaving the field. Those weevils aren't leaving the field during the day. They're not like a rice stink bug that can pick up, fly off, and go somewhere else. And it just seems like they're way more active in the evening.
Right. Yeah. We think they're moving up and down within the canopy of the plant, like that they're getting down in the water or the soil during these really hot temperatures.
But it does kind of seem like that ratio is about a 3-fold increase in the evening. So, I mean, I think it's going to be a lot like what we recommend with rice stink bug, whereas when you're in the heat of the day and you see them being flighty in front of you, probably only assume you're catching 50 or 60% of them. It'll probably be something real similar to that whenever we kind of come up with a threshold there. And to be honest with you, it's probably going to be one of them thresholds that's sort of a range, like what we got with adult plant bugs with a sweep net early in the year, where it's 8 to 12 there. It wouldn't surprise me if this one doesn't work out 10 to 15 or 15 to 20, something like that on 10 sweeps. I mean, it's noisy the way we're trying to do it, and there's also kind of an art to sweeping that real young rice. You know, everybody's used to getting in headed rice sweeping for stink bugs or getting in soybeans and sweeping, and you got to put quite a bit of effort in, and it really seems like the gentler you sweep this little young rice out there, the more you catch. So there's still a lot of educating to do there, but what we're trying to do is avoid the conversations that I have on a yearly basis where folks are seeing some out there, seeing quite a bit of scarring, and they want to know, should I treat or should I not treat? And at least now we'll hopefully be able to give them a number and say, if you're catching X amount, normally we would suggest treating it that. Gage has also been playing with a lot of foliar insecticides. He's been doing some assay work. You know, karate, lambda cyhalothrin, I guess it's Warrior 2, and a whole plethora of generics out there now. You know, that's kind of been the go-to. You don't have a lot of options from a foliar standpoint. You really got a couple pyrethroids, you got clothianidin and belay, but that's about it. You got Dimlin. Dimlin's difficult for us to use because there's an 80-day PHI. And if we're, you know, half the times, by the time we go to flood, we probably don't have 80 days left in the season before we're going to put a combine in it. And what I've been interested in, you know, like we've been doing foliar work since I've been here. Gus did a ton of it before I got here. You know, sometimes you see good control with lambda, sometimes you don't. And I want to know whether or not it could potentially be resistance, or if it's just the fact that we don't have any kind of residual there, you know, maybe 2 days worth of residual. And Gage ran a bunch of assays looking at a rate range there of lambda earlier this year, and it looks like it actually works fairly well. It's just a residual lack of
Residual or contact, because if at the time that we're spraying those weevils are in the water or elsewhere, we might not get as good a coverage as we may need.
So one thing I do want to mention, rice stink bug, one major change with it this year is we increased that early season threshold. So we're at a straight 10 per 10 sweeps through the whole season. We tell you don't get a sweep net out until you're at least 75% headed. And with the control issues we've seen with lambda since back to 19, I think, is when we first started doing assays, lambda's not a real option for us anymore. It's going to have to be a very specific window at that termination timing around that 60% straw colored, where 50% control is good enough there. Really, it's a tenchu market at this point. There's a generic called Kruger, a generic dinotefuron. It has looked fine so far in our studies. We got more work to do with it there. But that's the biggest change with rice stink bug. That threshold has moved. Instead of being 5 per 10 followed by 10 per 10, it's a straight 10 all season. With that, you know, as far as stink bug populations this year, they were extremely high in some areas when that rice first started heading. It kind of mellowed out. Now, northeast Arkansas right now is dealing with some pretty high populations, but it's kind of mellowed out around this area, except for a lot of this grain or a lot of these fields that we were watching like half threshold populations for the past 3 or 4 weeks, and now we're getting right there at that drain timing, and we've had big hatch outs, and now we're looking at needing to spray right there as we're getting out of the field. One thing we have done is looked at like some potential reduced rates there of tenchu to try to save a few dollars there late in the season. You know, 5-6 ounces, it looks fine. You're only going to get 7, maybe 10 days of residual. So I kind of view it like we used to recommend lower rates of Intrepid for loopers. If all I needed to do was knock them back or get 4 or 5 days out of it, that's kind of where them lower rates, that's where they kind of fit. If I need longer than 10 days, I'm going with a full 8 ounces. And what we've seen is that we can typically get 14 plus days of control out of it.